Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to discuss another problem. So let me give you the problem, then we will discuss the solution. The problem goes like this. A ball is thrown vertically upward from the ground with a speed of 25.2 meter per second. Part A, how long does it take to reach its highest point? And we have another part B, how high does it rise? Let me write it clearly. Then we have part C, at what times will it be 27.0 meter above the ground? This is our problem for today's class. Let me check the problem before moving to the solution. A ball is thrown vertically upward from the ground with a speed of 25.2 meter per second. Part A says, how long does it take to reach its highest point? Part B, how high does it rise? Part C, at what times will it be 27 meter above the ground? So it is the problem pertaining to free fall motion. We have already discussed the equations of free fall in the last lectures. So let us use the pertaining equations and solve this problem. Let us move to part A. You can see when ball is thrown vertically upward, at its highest point, its velocity passes through the value 0. So our final velocity v is 0 and v0 is given. We're throwing the ball with this velocity So our V naught is 25.2 meter per second, and we have to find the time taken by the ball to reach its highest point. So we can use this equation using V equal to V naught minus GT. We have to solve for the time. So solving for time, solving for T, what we get? T is V naught minus V over G. T is V naught minus V over G. Let us put the numbers. Let me use another color here. So our V naught is 25.2 meter per second. 2 meter per second minus V, which is 0. Then we have in the denominator acceleration due to gravity, which is 9.8 meter per second square. So we have V naught minus V over G, 25.2 meter per second. Let me write it a bit neatly. This is meter here, minus 0, which is our V, over acceleration due to gravity, which is 9.8 meter per second square. When we solve it, it turns out to be 2.57 second. So this is the answer of part A. Let me encircle it. So this ball will take 2.57 seconds to reach its highest point, right? Now, as always, you need to check this calculation. Check the calculation at home. Let us move to part B. Part B says, how high does it rise? So we will use this equation using V square is equal to V naught square minus 2G Y minus Y naught. V square is equal to V naught square minus 2G Y minus Y naught. You know the symbols. V naught is initial velocity, V is final velocity, Y naught is initial Y coordinate, Y is final Y coordinate. Motion is taking place vertically, and that vertical direction we are labeling Y direction. Upward we are taking positive, downward we are taking negative. So let Y naught be 0. That means the point at which ball is thrown, we take the origin of the coordinate system at that point. So using Y naught equal to 0, we solve for y. Solving for y. When we solve for y, we get y is v naught square minus v square over 2g. Y is v naught square minus v square over 2g. You can check it. You put y naught 0, then solve for y. It will become v naught square minus v square over 2g. So let us put the numbers. Let me use another color here. V naught is the initial velocity, the velocity with which ball is vertically thrown upward, which is 25.2 meter per second. And there is square. Final velocity is 0. The velocity at the highest point. Then we have twice 9.8 meter per second square. So what is the answer? 25.2 meter per second whole square minus 0 divided by 2 times g, which is 9.8 meter per second square. When you solve it, it turns out to be 32.4 meters. Check the calculation. Check the calculation. At home. So this is the answer of part B, 32.4 meter. This is the height attained by this ball. Now let us move to part C of the problem. Part C says at what times. That means there is more than one time when this ball is 27 meter above the ground. So we have to solve for those times at which this ball is 27 meter above the ground. So let us move for the solution of part C. Let me use the next page, part C. So we will make use of this equation using y is equal y naught plus v naught t minus half gt square. Y is equal to y naught plus v naught t minus half gt square. Y is final y coordinate, y naught is initial y coordinate, v naught is initial velocity, and t is time. So let us move to the solution. You can see t is the only unknown. So we have to solve for time. Y naught is 0 because the point at which we throw the ball upward, we set the origin there. So y naught is 0. When we put y naught 0, we get put y naught 0, we get what we get. We get half gt square minus v naught t plus y is equal to 0. Half gt square minus v naught t plus y is equal to 0. You can check it. When you put y naught 0, this term will go. Then You take these terms to the right, it will become y, v naught t will become minus v naught t, and minus half gt square will become plus half gt square. So you can see this equation is a quadratic equation in time. A quadratic equation in time t, right? So let me put the numbers first before going to the solution. It is half, then we have g, which is 9.8 meter per second square. Then I have t square minus v naught t. V naught is the initial velocity, which is 25.2 meter per second times t. What is our y? Let us move to the question. Question says, at what times will it be 27 meter above the ground? So our y is 27 meters. So our y is 27.0 meter, and we equate it to 0. So half 9.8 meter per second square times t square minus 25.2 meter per second t plus 27 meters. We know if we have a quadratic equation, ax square plus x plus c is equal to 0. This is a quadratic equation in x, and its solution is given by the quadratic formula. What is quadratic formula? X is minus b plus minus square root of b square minus 4ac divided by 2a. This formula is called quadratic formula. We write it somewhere. So it is quadratic formula. If we have quadratic equation in x, general form, ax square plus bx plus c is equal to 0, then the solutions of x are given by this quadratic formula, minus b plus minus square root of b square minus 4ac whole divided by 2a. So this is the same equation. You can see here half g is a, right? Minus v naught is our b, and plus y is our c. You can see ax square, here you have half g, t square, because t is the variable, so half g is a. Here minus v naught is b and y is c. So using this formula, using the quadratic formula, we get, I will write directly, we will solve the solution, you will solve the quadratic formula at home and check these values. So using the quadratic formula, we find the solutions to be, let me use another color. One solution is t equal to 1.52 second, and second solution is t equal to 3.62 second. One solution is t equal to 1.52 second, and second solution is t equal to 0.62 seconds. Let me encircle them. I want to understand this. So you have to check it at home. So we are saying that at t equal to 1.52 second and at t equal to 3.62 second, this ball will be 27 meters above the ground at these two times. Now, what is the difference and how it is possible for the ball to be at same position at two times? We want to understand that. To understand that, we will find the velocity of the ball at these two times. Let us move. At time t equaled 1.52 second, the velocity of the ball is given by the velocity of the ball is. So let us find v is equal to v naught minus gt. V naught is 25.2 meter per second minus 9.8 meter per second square times the time, which is 1.52 seconds. So V is V naught minus GT, 25.2 meter per second is V naught, minus G is 9.8 meter per second square, and the time 1.52 second. When we solve it, it turns out to be 10.3 meter per second. So at t equal to 1.52 second, the velocity of the ball is 10.3 meter per second. Now, let us find the velocity at another time. At time t equal 3 at time t equal 3.62 second, the velocity of the ball is, let me use another color, is v equal to v naught minus gt. V naught is again 25.2 meter per second minus g is 9.8 meter per second square times the time, which is 3.62 second. When we solve this velocity, it is minus 10.3 meter per second. Let me encircle it. Now let's understand it. At t equal 3.62 second, the velocity of the ball is v is equal to v naught minus gt, 25.2 meter per second minus 9.8 meter per second square times 3.62 second, which is minus 10.3 meter per second. That means you can check the two velocities have identical magnitudes but have opposite directions, right? That means at this time, this is ground. Ground is y naught equal to 0. And at, understand it, At what times will it be 27 meters above the ground? So if here y is, if here y is 27 meters, at one instant, this ball, and this is ball, ball is going up at one instant, and at second instant, ball is going down, right? Ball is going up with velocity. Here its velocity is 10.3 meters per second, because upward y we are taking positive. Here its velocity is minus 10.3 meters per second, right? Minus 10.3 meters per second. At first instant, time is 1.52 second. Here time is 1.52 second, and here time is 3.62 second. 3.62 second, right? This is the justification. That means at 2 times this ball is at same height above the ground, which is 27 meters. First instant it is 27 meters above the ground is when after throwing 1.52 second has elapsed. At the time it is going up with this speed 10.3 meters per second. Then at another instant 3.62 second, when 3.62 second have elapsed after throwing the ball is at same location 27 meters above the ground. At the time it's moving with same speed 10.3 meters per second, but it is going down. I hope you got the solution. This is all for today. Go through all these problems, enjoy doing these problems, and check all the calculations and make a notebook of it. And don't forget to like, share, and subscribe my channel. Thank you. God bless you. Assalamu alaikum.